Okay guys, so now I can find the direction vector of the line of intersection of this. So M will be the numbers, the coefficients of t. So negative 5 over 2, negative 4 and 1. I can use this to find the equation of the line, or I can use any scalar multiple. If you don't like fraction, you can multiply this by 2, so you get negative 5, negative 8 and 2. You can multiply by negative 2, but I wanted to keep it this way so you understand that I just copied this into here. So now the equation of the line, this line passes through A and parallel to the line of intersection. I can write it as L. I use the point R equal negative 2, 3 and 6 plus any letter for any variable for the direction vector. Then I'll use the components of the direction vector I got from the line. Okay? Alright, so this is, I answered the 3 questions. Let's say you asked me about 7D. Try to this is, the whole idea is I think, was about this part. And I explained it to you that the normal vector has x component equals 0 and how the plane looks like. This is a plane, not a line. So it is the same as number 7D. If you still have trouble, send me a message and I will do it for you. Okay? Actually, I have a long lesson. Maybe it will take 2 or more days. So, alright, so now we are going to learn about the intersection of 3 planes. Okay, before we start, I want to define something very important. There is 2 types of, we call those systems. 3 planes make a system, like linear system when we learned about 2 lines. 3 planes are systems as well. 3 equations. There are 2 types of systems: consistent and inconsistent. Consistent systems, when the 3 planes, all the 3 planes share a point or a line or a plane. The 3 share something. So I will draw 4 cases of consistent system. Please draw them and write them with the same numbers, because when we solve the system, I will tell you which case, so you can tell number 1 and you know what's number 1. It's in your paper. Okay? So the first case, when the 3 planes intersect in a point like this. Those 3 planes meet in a point. So this is the first case of the consistent system. The second case is when the 3 planes intersect in a line. So they share a line like this. This is like the pages of the book. The line here is common in the 3 planes. This is plane 1, this is plane 2, this is plane 3, 1, 2, and 3. They all share the same line. Case number 3, when we have 2 coincident planes, plane lie inside the plane. Two coincident plane and a third plane intersect those also share a line. So two coincident plane, 1 and 2, and the third one cuts them. Okay, this is the third case. The fourth case is 3 coincident planes. 3 planes lie on the top of each other. Okay, they share a plane. Okay, so those are the 4 cases of consistent systems, when the 3 planes share either a point or a line, or a plane. Okay, now I'm going to, so this is consistent. This is consistent system. So please draw those and have them numbered like this. Okay, that will make the next lesson, tomorrow's lesson, much easier. Okay, now we are going to talk about the inconsistent systems. We also have 4 cases of inconsistent systems. Those are when the 3 planes don't share anything. Maybe 2 of them share something, but the 3 don't have anything in common, point or a line or a plane. So the case number 5, which is the first case of the inconsistent system, when we have 3 planes like this, every 2 planes share a line. It is, I call it the lavash tree. It looks like the cheese. So these are 3 planes that don't share anything. So we can do it in a better way. Okay, it looks like the cheese, the lavash tree. So this is case 5. Case 6, when we have 2 parallel planes and a plane that cuts them. Okay, 2 parallel planes and plane that cuts them. This is another inconsistent system. The next inconsistent system, when we have 3 parallel planes, it is very clear that this is inconsistent, nothing is common. The 8th case is when we have 2 coincident plane and the third one is parallel to them. Coincident plane, I wrote one bigger and one small. Actually, they are the same, but I wanted to show you that here we have 2 planes that are on the top of each other. So these cases, when we have parallel planes or coincident planes, we can tell right away which case, because in here, for example, the 3 equations will be scalar multiples. The 3 equations will be multiples of each other. In here, these 2 equations will be multiple of each other, and this one, the normal vector, will be multiple of those. So we can tell this. This is also, these 2 will be a scalar multiple, and the third one will not be a scalar multiple. So we can tell this one. Case the case of case number 3, when we have 2 coincident plane, this will be the normal vectors, will be scalar multiple. Case number 3, when we have two coincident plane and one cut them, also we can tell because the equation of the planes that are coincident will be multiples, and the third one will not be a multiple of them. And when we have case number 4, when the three equations are, when the three planes are coincident, the three equations will be multiples. So the only cases that we need to do work to find the answer or to find what type is case 1, when they share a point, case 2, when the three planes share a line, and case 5, the Lavache-Curie one. And this is what we're gonna learn tomorrow, how to solve those systems, three equations. We're gonna use something interesting. We're gonna use matrices, and this will make solving three equations with three variables easy for us. Okay, I will stop here, and I answered your questions, and I give you introduction to how three planes can be in 3D, like all the 8 cases. Please draw the pictures and have them tomorrow for tomorrow's lesson in front of you, so we can tell this is case 1, this is case 2, this is case 5. Okay, all right, so have a wonderful day.